Hi everyone, I'm Dan Boneh. I'm a professor of computer science at Stanford University, and I work on cryptography. That was a long time ago. I first heard about FHE when it's still in grad school. It was my first year in grad school, maybe early 1990s or so. It was an amazing problem. I've worked on it for a long time ever since. I guess we have constantly been trying to build FHE systems. Since then, I guess one example that we did is the BGN system, which is a somewhat homomorphic system. It allows you to do arbitrarily many additions and one multiplication. And the question was how to do fully homomorphic encryption. That was, of course, open for a long time. And I have to say, every year when we have incoming PhD students to the department, the faculty go and give talks about their work to the incoming students. And for many years, the problem that I would always present, like I wanted like a big open problem to present to the incoming PhD students that they can work on. So the problem I always presented was fully homomorphic encryption. That was like kind of the cliff that I wanted everybody to work on and solve. And so for many years, that was like my problem until Craig Gentry became my student, and he also heard this as like my pitch that this is kind of the problem that needs to be solved that everybody should be working on. And fortunately, of course, he started working on it, and by the end of his PhD, he was able to solve it, which was fantastic. There was a little bit of bad news for me because then I lost my problem to challenge the PhD students with. So I had to invent a new problem to challenge the PhD students with. So I have a new problem now, thanks to Craig, that I had to come up with a new problem. And so, yeah, that's basically kind of my interaction with FHE, but I'm super happy and, I was very, very excited that Craig came up with the first FHE system. I guess what we were waiting for is a system, a public key encryption system where decryption time ran in linear time. So it was super fast decryption. We didn't have that until lattices came along, and then Craig realized, oh my God, once you have a linear time decryption algorithm, you can do bootstrapping, and then from there you can get fully homomorphic encryption. So very exciting times, and it was a fun time to do that. So what's my favorite FHE scheme? Maybe I'll give a little bit of a snarky answer here in that I believe my favorite FHE scheme is the scheme that has not yet been invented. Yeah, so I find it hard to believe that the only way to do FHE is through this bootstrapping mechanism. There should be easier ways to achieve FHE, what I like to call clean FHE, where you can just add and multiply plain texts that are encrypted, not having to worry about bootstrapping and noise and so on, and just compute on ciphertext. So I would encourage everybody to think about that. There's got to be other directions to build. There have to be other ways to build FHE. So hopefully we can get there at some point. But if you ask me of the existing FHE systems, which one do I like the most? I have to say I really like the GSW system. It's really easy to explain, at least in its basic form. It's a really simple FHE system. Of course, once you get into the bit decompositions and all that, things become a bit more complicated. But in its basic form, it's a really simple system to explain. So that's my favorite. I think it's a really good question. I think the applications for FHE are phenomenal. They're just it enables us to do computations without revealing what's with the data on which the computation runs. It's a phenomenal tool. It's really needed in industry. The best example I have of that is that FHE implies a very good private information retrieval protocol, and PIR, there's a lot of demand for that in industry, and so people try to use the existing FHE schemes for PIR. Of course, the performance kind of limits how big of a database we can handle. And so the reason I was interested in FHE is because it's just got so many applications that people care about. And so if we had a much more performant FHE, that would actually have a significant impact on the world. So clearly, again, performance is an issue. And so clearly the industry is going in the direction of hardware acceleration. In some sense, that is not good news, right? That the best way that we can get FHE to be performant is by throwing more hardware at the problem. I really wish we had more performant systems. So I do always encourage everybody to look for other directions to build FHE so that we have better performance, maybe even without having to rely on hardware. Oh yeah. So what about FHE should be improved? I guess we've already touched on that. Obviously, the performance needs to be improved. One thing that's interesting that I think would also be beneficial is to obviously improve the tooling around FHE. But what I mean by that is when you look at what's happening, for example, in the land of zero knowledge proofs, in the land of ZK SNARKs. So there, one of the reasons why it's become so easy to use and build SNARKs is because there's this notion of a virtual machine that you can literally just compile your program into like a RISC-V instruction set, and then just run the RISC-V instruction set in a virtual machine, and then do proofs on that. In FHE land, we don't have that. You can't just run RISC-V in FHE. You have to convert it into a circuit and then run the circuit. So it would be really great if there was more, if there was some way in which FHE would be made so simple to use that we could just run RISC-V code directly inside of FHE, and again, that would make it a lot easier to use. Yeah, I guess it depends a lot on what your interests are. I guess for engineers, obviously, there's a lot of room for better tooling. Like we just talked about, perhaps building better compilers, better virtual machines, better languages. So lots of room to play there. For the more cryptographers, I would say kind of the big problem to solve is again a new approach to FHE. Why is it that the only way we have to do it now is using noise and bootstrapping? There should be a different way to do it. I wish I knew how, but I mean, I have some thoughts. But obviously, everybody should think about their own path, and hopefully, in a few years, we'll have other ways to build FHE systems.